So last Friday, you guys did some graphing of absolute values. So just a reminder on that here. So loop for the vertex, the coordinate. That's where you start your graphing with these. And in general, we looked at, well, there's a number on the outside and the front. There's this number on the inside that's h, and a number that's on the very last, which we call k. And to find the vertex, you always look on the inside first. There's some number here, so we're going to use a 0. The number on the outside is -5. That means when we graph this, it's going to start at 0, -5. The number on the front right here is kind of like the slope. So if there is no number, we use 1 or 1 over 1, which means you go up 1 and then left and right 1 from there. Use your straight edge if you can. If you have one, if not, just try to do it as straight as possible. You can make a lot of dots go straighter that way. The reason why it needs to be straight is because your answer is going to be kind of like a system of equations. It's where these two are going to intersect. So if it's not straight, they won't intersect at the right place. So like here we have y equals 2. So we go to 2. Oh, you need to use straight. Go to 2, draw a nice straight line there. And from there, you can see the answers are the x equals. So right here and here where they intersect. So it's going to be at -7. If you're following down, this is x equals x-axis, -7 and +7. So our goal is to get those two answers, -7 and +7, by graphing. Okay. And by using algebra only, which means no graph. So we can get the same answers by adding to both sides and so on. That's going to be the goal of the whole week. A few things about notation is that we have two answers. Now, they're both x equals. One of them is x equals -7. The other is x equals +7. So we don't want to do this. How come? Because that means the first number is x and the second number is y. When it's in parentheses, it's like you're graphing -7, 7, which is right up here, which has absolutely nothing to do with your answer. So what we do is we use these braces instead of parentheses. Parentheses are reserved for x equals and a y equals. But we have x equals -7 and x equals 7, and we use these braces instead so we don't confuse that. So do not use parentheses here. You must use these braces. Okay. And then what you're going to do is I'm going to show you some steps for solving algebraically. Now, you already know most of it. So, for instance, if I said solve this equation, what would you do first? Add 5 to both sides. So you already know the basics of it. It has not changed. So we're still going to add 5 to both sides to start off. Your first goal when you're solving these is to get the absolute value, this part, by itself. So anything on the outside of it, you want to get rid of it. So if it's a -5, add 5. So we got absolute value of x equals 7. And you can tell we're pretty close to getting the right answer. Now, here's the big concept here. The absolute value of what number equals 7? So the absolute value of 1, someone said? Absolute value of 1 equals 1. So you want the answer to be 7, though. So the absolute value of 7 equals 7, right? What's the absolute value of -7? It's 7 as well. So whether it's an absolute value of positive or absolute value of negative, you get an answer of 7. So what we can do here is that when we have absolute value of a number, we can say, okay, that must mean x equals -7 and x equals +7. And that's how you get the two answers that we got from the graph. Once you get absolute value by itself, you can break it up and say, well, one is negative and one is positive. And that's all you need to show. to show that the answer is -7 and +7. And you can do the graphing first and then the algebra second, or you can do the algebra first. It doesn't really matter. It's the idea that either way you get the same answer. Let's see here. Let me show you. Let me skip down to number 3 real fast. And let's do the algebra first here. So you can see, as I mentioned before, the first step is to get the absolute value by itself on the left-hand side. You notice how there's nothing on the outside here. So we can actually go straight to doing the two equations. So instead of just having x, we now have an x minus 2. So we have two equations to solve. One is equal to -2, one's equal to +2. So once you have absolute value by itself, you can split it up into two parts. Some people like putting a little line in between. Separate. You got to have one positive, one negative. By the way, this has to start as a positive. If it doesn't start as a positive, it will not work. So I'll show you next. It has to be a positive number here, and then you can break it up into two parts, and then do the typical steps of solving, adding 2. The nice thing is, once you add these two equations, the algebra is identical. So to solve this one, you have to add 2 to both sides. Well, it's going to be the same thing over here. And that will always be true. So here we have two answers. One is 0. The other is 4. My solutions will be 0, 4, which means when I graph it, they should be intersecting at x equals 0 and x equals 4. So slightly different than the one we started with, because here this 5 was on the outside, so we started with adding, subtracting. On the third one, this -2 was on the inside, so we actually broke it up into two equations. Then we did the adding, subtracting, and that's going to be new and what we're going to have to pay attention to. All right, let's look at the graph. So the f of x and g of x just really means the left of the equal sign and the right of the equal sign. It's just calling them two different graphs. So we'll graph the left-hand side, absolute value of x minus 2, and then graph the right-hand side, which is 2. The right-hand side will always be that horizontal line. The left-hand side will always be the absolute value for everything we're doing. Okay. Now think back to up here in this format. Okay, where is the vertex? Where is the vertex here? Now, if it helps, you might remember that since there's no number here, it's really a 1 over 1. There's no number on the outside, so it's really a +0. So filling in those empty or missing values sometimes helps. So from that, the vertex is going to be, I'll give you a hint. The second number is 0. What's the first number? What is it? Positive. +2. So you remember that it was always the opposite of this sign. If this was a negative, it's going to be positive, and vice versa. If this was +2, this would be -2. Always the opposite sign. And then the slope will be at 1 over 1. Okay, so to graph this, I'm going to start at +2, right there, and then go up 1 over 1 in both directions. Use the straight edge. And again, if they're not straight, well, they may not intersect at the right answer. So it's going to be crucial to use something straight. Again, folding a piece of paper works just fine. You don't have to measure anything. You don't actually need a ruler to do these. And then 2. And as you can see, they intersect right here, which is 0, and then right here, which is 4. So I get the same two answers, whether I start off with the graphing and then solve algebraically, or like on this one, if I start off with the algebra and then solve graphically, get the same thing. Okay. Next, I just want to show you one more, and then we're going to try some together. let's graph, I'm going to graph this one. So I have absolute value of x plus 4, and then the right-hand side is -3. So the vertex, no number on the inside, so it's 0. Number on the outside is 4. There's no number in front, so that's going to be 1/1. A is 1/1, the slope. So we're going to start at 0, 4, and up 1/1. Up 1/1. Remember, with absolute value, it's up 1/1 in both directions. There we go. And now graph -3. All right, so what's the answer? Where do they intersect? All right, the answer is the intersection, right? Like here, they intersected at -7, 7. Below, they intersected at 0, 4. Where do they intersect here? Absolutely nowhere. So you end up with a no solution. So you can have no solutions here. So very similar to the system of equations when we were graphing them before. When they came out to be parallel lines, you might remember we got no solution there because they didn't intersect. Same idea here. They don't intersect, so there are no solutions. Now, how does that look algebraically? So remember we had a -5 on the outside, so we added 5. So same idea. We have a +4 on the outside, so we're going to do the opposite of subtracting 4. Now here's the problem. It comes down to the absolute value of what number equals -7. So what number can you take the absolute value of and get a -7? And the answer to that is impossible. You can't take the absolute value of a negative. Okay, so once you're asked to take the absolute value of a negative, that's your cue for no solution. I mentioned briefly right here that must be positive, because if it's positive, that means you can break it up into your two parts, one positive, one negative. However, if it starts off with negative, you're simply finished. There is no solution. And then you could expect the graph to be something that does not intersect with one another. So that is the basics of this graphing. Pause that. 7. It is. Yeah, let's look at number 7. So that way it'll be the third and final case or type of problem here. So see if you can figure out the vertex and the slope for this. So the vertex would be no number on the inside, so it's 0. What's the y coordinate? Yeah, number on the last number. What is the slope here? Okay, so that's the number in front, so -1/1. So we're actually going to be going down 1, and then left and right. So it'll be opening downwards. Remember that sign in the front dictated whether it opened up or down. So here we have 0, -5. There we go. And down 1/1. Down 1/1. Make that a little bit bigger. There we go. Straight edge, straight edge. Yep. And then we have the red y equals -5. So we're going to go down 1, 2, 3, 4, 5. And there you have it. How many solutions are there? Well, this time they only intersect at the vertex, which is 0. So we only have one solution, which is at 0. The reason I want to show you this one right now is because we had several that were solutions. Number 2 in the front was no solutions because it didn't intersect at all. And here you have the third and final case where they intersect only at one place, which is the vertex. So it's very difficult to get one solution because it has to be exact. All right, two solutions. This y could be anything less than -5, and it'll be two solutions. Any number bigger than -5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it'd be no solution. But there's only one exact number that will give you a one solution answer. So it doesn't happen too often. Now, what happens algebraically when there's only one solution? Well, what number for absolute value only has one solution? So here we have a couple things on the outside. We have a -5 on the outside, and we have a multiplying by -1. So just like before, if you had something like this, like -x minus 5, and let's say just equals 20, you guys know you would add 5 to both sides and then divide by -1. That does not change. Do the exact same steps. You're going to add first, divide later. So let's add 5 to both sides, like you always have. Then we'll have -1. Absolute value of x equals 0. Okay. Then divide by that -1. Whatever number's in front, divide by it. So now we have absolute value of x equals still 0. 0 divided by -1 is just that 0. Now the question becomes, the absolute value of what number equals 0? Right? So before we had something like, this equaled 7. Well, the absolute value of +7 and the absolute value of -7 both equal 7. But here it's different because there's no such thing as a +0 and -0, right? There's only 0. So that's how we get only one solution, is because there's no positive and negative of 0. It's just a 0. So x equals 0, that's our only answer here, which matches the graph. It only intersected one place, and that's at 0. So those are the three different types of answers with one solution. And then on the front, we had 1 and 3 that had two solutions, but number 2, you can't have a negative when you have an absolute value. It doesn't make sense, so we have a no solution. All right, number 3 and number 4 are very similar. So if you haven't already, go ahead and start number 4, using number 3 as the guide. Just transplanting some of the numbers and doing the opposite operations, just like we did. So test to see how well you can do this on your own right now. So do we want to do the graphing or the solving first? Doesn't matter, you get the same answer. So nothing is on the outside of the absolute value. So we go straight into breaking up in two parts. Okay, so we have absolute value of x plus 6 equals -1, and absolute value, sorry, I already did it wrong. You don't need the absolute values here. So the idea of breaking up into two parts is when you drop the absolute value. So x plus 6 is going to be -1, and x plus 6 is going to be +1. So whenever you have only absolute value, that's when you can break it up with 1 equal to a negative, 1 equal to positive, assuming this is starting off as a positive number on the right hand side. Right, then we can go ahead and solve. Subtracting on both sides. And go ahead and solve that. We got -7 and -5. So two answers, -7, -5, that we need to confirm with the graph. Yep. So the left side was absolute value of x plus 6. The right-hand side was, what was it? 1. There we go. And I've been filling in the missing numbers here, so if you like that, you can put no number on the last part. You can put the plus 0. If there's no number or no slope in the front, you can put that as well. That usually helps when you don't have those missing numbers. So vertex, remember, it comes from these two. So anytime you're looking for the vertex, it comes from the last two numbers. You just got to be careful, though, because it's always the opposite sign. If that's negative, I mean, if that's positive, it's negative, and vice versa. So this one's positive, so it's going to be at negative 6, comma 0. And then make sure you go the right direction, negative 6, comma 0. It means x is negative 6, y is 0. So x, negative 6, y, 0 is right there. And then, of course, the slope, the a, is just 1 over 1. A lot of these are going to be 1 over 1. We'll get into different slopes next assignment. And then the g of x is positive 1. There we go. So right here, if you count it out, that's negative 7. Count this out, that's x equals negative 5. So it matches our two that we got algebraically. All right. So flip it over. Go ahead and start number 5. See how you do. You'll get better and better at it the more you try at it. So this time we can do the graphing first. Just remember that the left side of the equal sign is the first function. And the right-hand side is the second function. So the right-hand side, or the second function, is always just a number. The right-hand side, or the left-hand side, is the absolute value. Absolute value of x minus 2. So if you need those missing numbers, you put those in there. So a negative is the same as negative 1, or negative 1 over 1. Having no number over here is the same as plus 0. So we have vertex of 2, positive, opposite sign is negative, so opposite sign is positive, 0. And the slope is going to be down 1, and then left and right 1. So 2, comma 0, and then down 1, left 1, down 1, right 1. All right, and then the blue, let's see here. The negative 6 is always a horizontal line, so down 1, 2, 3, 4, 5, 6, right there. Oh, what just happened? Jumped me. There we go. There we go. So we have two solutions, right here and right here. Negative 4 and positive 8. So we should be having two solutions, negative 4, positive 8. Now, if you accidentally went to the left 2 and your vertex is at -2, you probably had these signs, same number, but the signs were reversed. You probably had a +4 with a -8. So you're close, but just shift the opposite direction as you see here. So when we do here, remember, get rid of anything on the outside of the absolute value first. So here's absolute value. We do have one thing on the outside, that's this negative, or -1. So the first thing you want to do is divide both sides by that -1. And now we get equals +6. And that's important because at first it might look like this is a no solution because the absolute value equals a negative. But because of the negative on the left-hand side canceling on the negative on the right-hand side, we do have 2 solutions. So now that we have only absolute value, that's when you break it up into your 2 parts. X minus 2 is -6, and x minus 2 is +6. So 1 positive, 1 negative. That's how you go from having absolute value to not having absolute value. You write 2 equations, one with a positive, one with a negative, and then solve. Same algebra for both, add 2 to both sides. X equals -4. That checks out here. And x equals +8. That checks out here. And of course, if you want to do a check, you can always go to Desmos, click Start Graphing, especially if you have the app on your phone, right? And then you can verify for sure by plugging it in. -1 absolute value of x minus 2. So just type it in exactly as you see it. -1, it's a little bigger. Absolute value of x minus 2. Right, so you can see that graph. And then the second line will be -6. Yeah. And then you can see your 2 answers, x equals -4, x equals 8. Of course, they're going to be comma -6, but we don't really care about that. We already knew that's what it's going to be. So Desmos is a good tool. Of course, if you just copy it down, don't really know how to do it on your own, it doesn't really count for a whole lot, especially when it comes to quizzes and tests. It doesn't really matter. You get the answers from somewhere if it's somewhere else other than your own mind. All right. So I'll leave you with that and pass out the assignment that goes with this, and you can work on that for homework, and we'll come back tomorrow and finish it up if it's not already finished. But I want to have it done tomorrow.